Scientists believe they've found evidence of a potential ocean beneath our home planet's crust. The study from researchers at Northwestern University and the University of New Mexico have concluded the body of water rests about 400 miles underneath Earth's crust and is so large it can fill all our oceans 3 times over. Their research, however, indicates the water is not in the typical liquid, ice, or vapor forms, but instead is trapped in mantle rock containing a blue mineral called ringwoodite. Ringwoodite has a structure similar to crystal that acts like a sponge to trap liquid and pull in hydrogen.
Ringwoodite have been proposed as one of the major minerals in the deep earth for the past 50 years, but no one had ever held a piece of ringwoodite in their hand that had come from those depths to be able to prove that that's the case.
Thus far, only one small piece of ringwoodite has been brought to Earth's surface from 400 miles underground by volcanic activity and was found to contain water in solid form. The researchers combined lab experiments on mantle rock under high pressure with seismic data measuring U.S. earthquakes to reach their conclusions. The discovery is an important one, as it will help scientists learn how the Earth formed and its current composition. Northwestern geophysicist Steve Jacobson, who is a co-author of the study, commented, "I think we are finally seeing evidence for a whole Earth water cycle, which may help explain the vast amount of liquid water on the surface of our habitable planet." Scientists have been looking for this missing deep water for decades.
Researchers at Northwestern University have found evidence for a massive reservoir of water deep within the Earth's mantle. The reservoir, which is said to be 3 times the volume of the oceans on the surface, is contained within highly pressurized rock known as ringwoodite. The scientists hope that their findings, recently published in the journal Science, can shed light on where Earth's oceans came from. The team, led by mineralogist Stephen Jacobson, used an array of 2,000 seismometers to study how seismic waves generated by earthquakes move through the Earth's interior. The waves' speed change depending on the type of rock they pass through, and wet ringwoodite has a particular effect on wave velocity. Jacobson was able to reproduce wet ringwoodite in his lab, and the group's findings matched what he observed in the lab. As it turns out, ringwoodite, under the extreme heat and pressure of the mantle, bleeds water. That water would then become trapped in the transition zone at between roughly 200 and 400 miles underground. The new research lends credence to theories that our oceans originated on Earth. However, more tests will need to be conducted moving forward. Jacobson's team could only verify that the reservoir exists below the continental United States, so it's unclear how far this ocean extends.